Hello, good evening. So today in this video, I'll discuss one problem based on friction, and it's from laws of motion. So those who are following NCERT book, you can find out this question in example 5.9, or I'll also write down this question, and you can also, without book also, you can try this question. So example 5.9. So the question is, what is the acceleration of the block and the trolley of the system shown in figure 5.128? So the figure is, this is like a table, okay, and one object is on this table, that is that block mass is 20 kg. So one block is there, its mass is 20 kg. Okay. Now one pulley is connected here and a string is connected, and another mass is hanging. This mass is 3 kg. Okay, and there is some friction between the surface and the object. It's not frictionless, it has some friction, and the coefficient of kinetic friction is given. So what is given? Mass of both trolley and the object which is hanging, both the masses are given. This is 3 kg. Let's say this is M2, this is M1, and the coefficient of kinetic friction, that is between the trolley and the surface, mu k is given 0.04, and also it's written G tech G is equal to 10 meter per second square. Now calculate, neglect the mass of the string. We will not consider the mass of the string. So what we need to calculate in this question? We will calculate what is the tension in the string. The question is, what is the tension in the string? Tension is a force, you know, and also you can calculate the acceleration also. Okay, so let us do that calculation. So it's not frictionless, as I am saying you. It's not frictionless, means there is some friction between the surface and the object. So as the object is hanging here, the motion is supposed to be downward direction. So let's say the acceleration is downward, and the second mass, that M2, is hanging here. So the mass is hanging, that means what? Due to its weight, M2G will be downward. The gravity will pull it, no? So M2G downward, tension upward, here also tension towards right, friction along the means opposite to the motion, because as this object is going downward, the M1 will go to the right side, accelerate towards the right side. Clear? Now how will you draw the free body diagram? That is very important. In motion chapter, laws of motion, free body diagram is very important, right? So how will you draw the free body diagram? You can draw, one is here and another is one here. For two cases you can draw the free body diagram. From the free body diagram we'll write down few equations, okay, because linear equations we will get here. So once you will get these linear equations of few unknown quantity, you can use the technique that you know, your substitution, elimination, or cross multiplication technique to solve the unknown quantities. So how will you do that? Let us draw this one. This one. So this is the mass, which is 3 kg. So M2G downward, that means 3 into 10, 3G also I can write, tension in the upward. So if I write for this free body diagram, if I want to write the equation, the acceleration is downward. So I'll write 3G minus T is equal to, because 3G minus T is the net force on this object that is creating the acceleration MA or M2A. This is your equation number 1. Clear? Now I'll do this diagram for this one, the mass M1. So for mass M1, the tension is to the right, friction to the kinetic friction to the left. There are two more forces. One is M1G. It's at a certain height, right? Also, gravity will pull it. So there will be some force here. So due to its weight, and normal force perpendicular to the surface. Okay. I have also discussed in my previous videos that what is the relationship between friction and the normal force. You know that F is equal to mu Kn, or Fk is equal to, okay, this is the relationship, or F by N. F by N is your tan theta, right? F by N is your tan theta, or your coefficient of friction, mu K, okay, or Fk is equal to mu. So you can write this, and also from here you can see in this diagram that N is equal to your M1G. We can also write this one. Why we can write? Because there is no acceleration along y direction. If there is no acceleration, that means we can say net force is 0, or we can write that N is equal to M1G. This must be equal so that the net force is 0 on y direction, or there is no acceleration in the y direction. So we can write, or we can write, if I'll put this N value here, I can write Fk is equal to mu K M1G. So why I'm doing it? Writing this, I will use it in my equation. Clear? So this free body diagram, N upward, M1G downward. So N and M1G we have written here. N is equal to M1G, one expression, and the another one is object is accelerating towards the right side, or the acceleration is towards right. That means what can I write? I can write that your T minus Fk is M1A, equation 2. Clear? Because the object is going towards right. So we can write T minus Fk is equal to the net force, which is creating the motion. So the net force is equal to M1A. That is the mass into acceleration. So T minus M1 Fk is equal to M1A. Now you have two equations. Few variables are there, acceleration and tension. Two variables are there, right? Two linear equations, two variables. Easily we can find out the unknown quantity. Easy or not? So just let me do it. Either elimination or cross multiplication I'll use. So let me write again this equation. That equation 1 implies that I can write 3G means G. In the question it is given that take G is equal to 10. So 3 into 10 I am writing directly 30 minus T. M2 is 3. So it's 3A. This is, let's say, equation 3. Now again equation 2 को भी थोड़ा सीधा कर देते हैं. So equation 2 will become what? Equation 2 will become T minus Fk. Fk we have written already the relationship with Fk. So minus mu K. M1 is 20. G is 10 is equal to M1A. M1 is 20A. This is, let's say, equation 4. Now add these two equations, 3 and 4. add these two equation 3 and equation 4, then what you will get, elimination technique we are using, minus t plus t will cancelled out, so let's left 30, ये कितना होगा, mu k is given also 0.04, so 30 minus 0.04 into 20 into 10 is 200 is equal to 20a plus 3a, right? So here you can calculate 30 minus, this is 4 to 8 is equal to 23a, this is equal to 22 is equal to 23a, and this equal to a is equal to, you can divide it, right? So you will divide it and you can find out this is 22 upon 23. So once you get the acceleration, now easy for you, right? Now it's easy for you to calculate the tension. To calculate the tension, you can easily calculate. How will you calculate? So put this acceleration in either in any of the equation, either equation 1, 2, anything, any equation. So I'll put in equation 1. So 30 minus t is equal to 3a. So 30 I'll take right side. So 30 minus 3a is equal to t, or 30 minus 3a. A is, we have already calculated a. So 3 into 22 upon 23, I think all of you are getting. So t is equal to 30 minus 66 by 23, or 23 is, else you can take LCM, 30 into 23 minus 66. So you can do some calculation, right? And this will be your 3 3 are 9, 69, 690 minus 66 by 23. So this will become 4, 8 minus 6, 624 by 23. Okay, Newton. Or if you want to convert it into decimal number, you can do also. So T is equal to 624 by 23, that is, you can do it 23, 2 ja 46, 46, 46, 56, 10, 10, 6, 16, 164, 23, 6, 7, 23, 7 ja 21, 2, 151, right? So this will be 3, 1, then 0 will come, so 27 point will come. So 27, so it will be approximately, to make the calculation, it should be approximately 27.1 Newton. You check it if it is correct or not, in some mistakes, but it should come 27.1 Newton. Okay, so this is the procedure to follow, how you will solve the equation, how you will draw the free body diagram, okay, and how to solve this linear equation. It's very important. Once you are clear on this, you can solve similar many questions. This is the fundamental of your laws of motion. Thank you. In the next video, I'll solve some more questions.